How's it going, ladies and gentlemen? Mr. Johnny here again, looking at 16.5 stuff where we're going to talk about strong acids and bases. Our objectives are to explain what makes a strong acid or base strong, identify the common strong acids and bases, and be able to determine the pH of solutions based on the strong acid or base concentration. So that's what we're trying to get done. All right, so strong acids and bases. Basically, what that means is they're going to dissociate and completely transfer the protons to water molecules. So they exist entirely as ions in solution. So if I had something like this where I have HCl as my acid over here, it's going to completely dissociate and give that proton to the water molecule. All of them are going to do that. All right. Weak acids and bases are a little different. They only partly dissociate in solution. They're not going to break up completely. If these are all my hydrogen fluorides, only a couple of them might break apart and dissociate into ions, right? So that's a weak acid or a base. So strong acids, the most common ones that we're going to see are going to be hydrochloric acid, hydrobromic acid, hydroiodic acid, as well as nitric acid, chloric acid, perchloric acid, and sulfuric acid. So these are the common ones. Basically, I just remember like group 17, I got those three, and then I got threes, and then I got fours, and I remember that two of these are CLOs. I remember SO4 and the NO3. You just got to memorize. There's no real good trick to these. Got to just memorize them. So strong bases, anything that's a group 1 hydroxide. So anything that's in group 1, like say, for example, sodium hydroxide, that is a strong base. They will break apart because those group 1 elements are completely soluble, so they're all going to break apart. And then there's three other that you got to remember: calcium hydroxide, strontium hydroxide, and barium hydroxide. If you look on the periodic table, you see that these three are in the same group, and they're in order, right? So the heavier ones in group 2 are our strong bases. You got to memorize those. No easy way around it. So determining the pH of a strong acid. First, you need to figure out what is your H plus concentration. Then you need to plug it into the pH formula. Pretty straightforward. So what is the pH of a 0.025 molar solution of HCl? Well, I know that if it's HCl, it's monoprotic, so I'm only going to get one H. I don't have to worry about messing with it. So this 0.025 is my concentration of H+. So I know that pH is equal to the negative log of H+, so it's going to be negative log of 0.025. And I'm going to plug that into my handy dandy calculator, which I got to turn sideways so I get those things. So negative log of 0.025, and I get a pH of 1.6. So that is my pH. So what is the pH of a 0.005 molar solution of HClO4? All right, same deal. I'm going to look at HClO4, and I'm going to see that it is just 1H. All right, so I know that this concentration is the concentration of my H+. So negative log of 0.005 is going to equal 2.3. And that's how you solve these ones. Pretty straightforward. All right, so if you got a strong base and you got to do or solve for the pH, there's a couple paths you can take. So first thing that you always have to do is figure out the OH minus concentration. So if you had something like NaOH, well, that's a strong base. I know I'm going to get a 1-to-1 ratio. So the concentration of NaOH is the concentration of OH minus. But if I had something like calcium hydroxide, where I get 2 hydroxide ions, then you got to take the molarity of calcium hydroxide and times it by 2, because you're going to get twice as many OHs or OH minuses. So you start here. There's two paths you can take. You can go, all right, well, if I know Kw is a constant and I know OH minus, I can figure out H plus. And once I got my H plus concentration, I can plug it into my pH formula and get the pH. That's fine. It's not my personally preferred method. I would rather go, all right, I know my OH minus concentration. Let me plug it in to the POH equation to get a nicer number, in my opinion. So once I got the POH, I know that, pH and pOH have to equal 14. So I can do some simple math there to give me my pH. So let's look at a practice problem. What is the pH of 0.025 molar solution of NaOH? First, you got to figure out the OH minus concentration, which in this case it's going to be the same thing. So it's 0.025 because I get one OH minus from each NaOH. Second, plug it into the pOH. So negative log of 0.025 gives me beep bop, boop, 0.025. It's going to give me 1.6, which I think I had on the other page. So now I go, all right, well, what's my pH? Well, I know 14 minus pOH is going to equal pH. So that's going to be 14 minus 1.6. That's going to give me 12.4. And that is how I would solve this problem. So let's look at another one. What is the pH of a 0.0052 molar solution of calcium hydroxide? So first thing is figure out the OH minus concentration. So now I'm looking, it's calcium hydroxide. I get 2 hydroxides from this strong base. So the OH minus concentration is going to be 0.0052 times by 2. And I'm going to get 0.0104 if I did that math right in my head. So next step is to plug it in for the pOH. So I need to take the negative log of that number, 0.0104. So negative log of 0.0104 is going to equal 1.98. So now, last step is figure out the pH. So I know pH is going to equal 14 minus the pOH. So that's going to be 14 minus 1.98, and I'm going to get 12.02 as my pH. And that's how I'm going to do that. All right? I think that's everything. No, it's not. I lied. Other strong bases. So later we'll encounter metal oxides, and they are and similar compounds that react with water to form OH minus. So basically what's going to happen is I get some sodium oxide right here, and it is going to dissolve in water and break apart. So these ions are going to break apart. I'm going to get 2 Na pluses. I'm going to get an O minus 2 ion. Now this oxide really wants a hydrogen to hold on to. It's a strong base. That oxide is going to steal a hydrogen from another water, and wouldn't you know it, we just now made 2 OH minus ions. So that's how metal oxides are going to be strong bases. We'll see more of that later. All right, that's actually everything. Hope you found this helpful. Bring questions to class. I'll see you there. Okay, bye.